This is the third part of our notes for section 3.6, which includes transformations of the graphs of sine and cosine function. If you have watched the previous two videos, then we have done a general case of a transformation like the one that is at the top of page 3 of our formula packet. So ideally here, you will want to try to solve these next two problems on your own, and then watch the video to compare your work to the work shown in the video. Again, if you are still not familiar with graphing the transformations, maybe you can watch the video and then try the homework. So we have the expression f of x equals a cosine bx minus c plus 2 plus d, I should say. I have identified that from my formula packet, the equation that I am looking at is the one at the top. I need the values of a, b, c, and d so that I can use the summary from my formula packet to identify characteristics of this graph. So a is 1/2. That means that my amplitude will be equal to 1/2. B is also 1/2. That means that my period is 2 pi divided by 1/2, which is 2 pi times 2, so 4 pi. And that means that the quarters of the period that I need for my critical points will be 4 pi divided by 4, which is pi. My c is equal to pi over 4. Therefore, the phase shift or horizontal shift will be pi over 4 divided by b, which is 1/2. So multiply that by 2 pi over 4, or pi halves, to the right. And my d is equal to 2, which gives me the midline of y equal to 2. This is a cosine function with a being positive. So if this is my midline, the cosine graph will go like this. The midline is y equals to 2. The amplitude is 1/2. So this is 2 plus 1/2. This is 2 minus 1/2. And the phase shift is the x-coordinate that begins one of the cycles I'm going to graph. And the phase shift is pi divided by 2. Every other critical point is an increment of quarter periods. So that will be plus pi, pi being the quarter period, plus pi, and plus pi. So pi over 2 plus pi will be 3 pi over 2, plus another pi will be 5 pi over 2, plus another pi will be 7 pi over 2, and plus another pi will be 9 pi over 2. So these are the values, the x-coordinates of the 5 critical points. And I know their y-coordinates because I know the midline and the amplitude. So I'm ready to graph. I'm going to go to pi over 2, and then 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, and 9 pi over 2. The midline is y is equal to 2. I have a high point, a midline, a low point, a midline, and a high point. The graph will look like a wave. Remember that the graph actually continues. I'm just graphing only one wave, right? One cycle. So don't make it be a V, don't make it stop, like indicate that it will continue. So maybe a good idea would be to draw some dotted lines so that you know that it continues. I need those coordinates. So the first point has pi over 2 for x, and the y is 2.5. The first quarter will be 3 pi over 2 for x, and the y is the midline. The second quarter is 5 pi over 2 for x, and 2 minus a half, so 1.5. 7 pi over 2 is at the midline, so 2 for y, and 9 pi over 2 is at the highest point, which is 2.5. Let's do our next one. This is a sine of b parenthesis x minus e plus d here. So I have identified that this equation looks like this. It is also a sine function. The a is equal to -1. That makes the amplitude equal to 1, but the graph reflected. Notice that this is a sine graph, so instead of starting at the midline and going up, it will start at the midline and go down. So remember that when you graph. I have a b equal to pi. So the period is 2 pi divided by pi, which is equal to 2. And that means that the quarters of a period will be 2 divided by 4, which is 1/2. I have an e equal to -1. That makes the phase shift equal to -1. And then I have a d equal to 4, which makes a midline equal to y equal to 4. So again, this is my midline. It is a sine graph that it is reflected, so it's going to go like that. The midline is y equal to 4. The amplitude is 1, so this will be 4 plus 1. This will be 4 minus 1. The starting point here will be at phase shift -1, and every one of these quarters will be a 1/2. So plus 1/2, plus 1/2, plus 1/2, and plus 1/2. So if I start at -1 and I add 1/2, I will go to -1/2, and add another 1/2, I will go to 0, and add another 1/2, I will go to 1/2, and add another 1/2, and I will go to 1. So my 5 points have x coordinates -1, -1/2, 0, 1/2, and 1. So I'm going to go here, -1, -1/2, 0, 1/2, and 1. The line, the horizontal, the midline is y equal to 4. And I will start at the midline. I will go down. I will go back to the midline. I will go up, and I will go back to the midline. So this will be my cycle. And again, remember, it continues. I'm just not graphing it for my test. And I need those coordinates. So this is -1 with the midline of 4. This is -1/2 with the lowest point of 4 minus 1, which is 3. This is 0 with the midline for y equal to 4. This is 1/2 for x, the highest point, which is 4 plus 1, 5 for y. And this is the rightmost point of the first cycle, 1 for x, and the midline y equal to 4. We have two more examples, and this will resemble some of the homework problems. They are asking us to use a graph and determine the amplitude, period, phase shift, vertical shift, and midline. We do want to have a phase shift of equal to 0. If we can, we'll make our equation simpler. If our phase shift is equal to 0, then I will have a C or E equal to 0. So I will only have a factor of X inside the function. The reason I want to do that is because actually the cosine and the sine are 90-degree transformations of each other. So if I have a cosine curve, if I had moved 90 degrees earlier, it would have been a sine curve. So I can choose to start at the top, or I can choose to start on the midline just by selecting a sine or a cosine curve. Therefore, I'm going to try to have a phase shift of 0 and just select the correct function here, or the appropriate function. There is no correct function. So in this particular case, I'm going to try to have a phase shift of 0. This graph starts at the top, so I'm going to use a cosine function. So I'm going to have a times the cosine of bx plus d, and I will not have a c. So the first thing I want to do is I want to find the midline. The midline will give me d. So the highest is at y equal to 4. The lowest is at y equal to 0. And the midline is the middle of those two. So if I do 4 plus 0 divided by 2, which is 2, that will be my midline, and that will also be my d. So d is equal to 2. So I have here plus 2. The amplitude is the distance from the midline to the top and to the bottom. That distance is 4 minus 2. It's also 2 minus 0. And that will be 2, and that's A, the amplitude. So A is 2. And what I'm looking for is what happened to the period so that I can find B. And the period from the one highest point of the wave to the second highest point of the wave, I'm going from 0 to 8. So the period is equal to 8. The period is also 2 pi divided by B. And I'm going to solve this equation for B. So I'm going to multiply by B. 8b is equal to 2 pi. And therefore B is equal to 2 pi divided by 8, or pi quarters. So the equation of this function is 2 times the cosine of pi quarters, x plus 2. So you can try on your own example 6, which is the next example in our notes, and then stop the video, try the problem by yourself, and then try to see if you got it correctly. And again here, I'm going to try to not have a phase shift. So I'm going to try for this h or e to be equal to 0. So I'm going to have a sine function. Because it starts at the midline, it goes down. Because it goes down, I'm going to have a negative a. That's what will make my wave go down. This will be a sine function. So I'm looking for a times the sine of bx plus d. I will not have h or e. So what is my midline? the highest point is 2. The lowest point is -4. 2 plus -4 divided by 2 is -1. That's the midline. And therefore, D is equal to -1. So -1 here. The amplitude is the highest minus -1, also -1 minus -4. So that is equal to 3. Therefore, the absolute of A is equal to 3, but I want A to be negative. So my A will be -3. And I'm going to use the period to identify the B. The period from the start to the next middle is 0 to 6. Also, from the lowest point here, which maybe is 1.5, to that lowest point is 7.5. It looks like that. So the period is 6 minus 0. It's also 7.5 minus 1.5. Therefore, it's 6. 6 is 2 pi divided by b. So I need to solve this equation for b. I'm going to multiply by b. 6b is 2 pi. And divide by 6. B is 2 pi divided by 6, or pi thirds. So here I will have pi thirds x. So this is my function. My function is, and again, don't write just an expression, write that equal to f of x, right? This is equal to f of x. My function is -3 sine of pi thirds times x minus 1. And our last one is actually a word problem. And we want to see if we can translate this word problem to a sinusoidal graph, which is a sine or a cosine curve, and then write the equation. So outside temperature over a day can be modeled as a sinusoidal function. The high temperature, that's the highest y, will be 96 degrees, assuming this is Fahrenheit. The lowest is 64 degrees. And this lowest occurs at 4 a.m. Assuming T is the number of hours after midnight. So T is number of hours after midnight. Find an equation for the temperature D in terms of T. So let's see if we can understand how it goes. We have a lowest of 64. We have a highest of 96. These are degrees Fahrenheit. The day is 24 hours. So I have 4 here. That's when the lowest occurs. And then 12 later will be 16 hours. 16 will be 4 p.m. And that will be my highest. And then for 12 later, it will be 24 plus 4, 28. And that will be my lowest. So I'm expecting to have a graph like that. And then it continues here. So this is a cosine function. It also starts from the bottom, so I want the a to be negative. I'm looking for a function of the form f of x equals a cosine bx, let's say minus e plus d. So if I have it in this factored form, then the horizontal shift is just e. And since I know that it starts at 4, then my e will equal to 4. and I will have x minus 4 in the parentheses. What is the midline? The high is 96 and the low is 64. So the midline will be here in the middle. That will be 96 plus 64 divided by 2. That is 150, 160 divided by 2, which is 80 degrees. So that is my D. So plus 80 degrees here. What is the amplitude? The amplitude is 96 minus 80, which is 16. It is also 80 minus 64, which is again 16, but A is negative. So my A will be negative 16. And I'm missing B. Now, I know that the period is 24 hours, and that will be 2 pi divided by B. Therefore, 24B will be 2 pi, and B will be 2 pi divided by 24, which is pi over 12. So pi over 12 times the quantity x minus 4 will be in the expression of the cosine. So this is my function f of x. And let me make some room here for me to write f of x.